I'm going to, you have to put them in parentheses. So here's a weird thing. I got to do a lot of parentheses on this one. I'm going to say x minus 6, that's the numerator, in parentheses, divided by the denominator in parentheses, x minus 3. I have to put a test on that, or a domain restriction or boundary. I'm going to say x, and then I have to say second math, which pulls up the test, less than or equal to, which is option number 6, 0. All right? So that's the first part of the function. Plus, now I've got to plug in the second part of the function, which is going to be 1 divided by x squared. Put that in parentheses. Right next to it, I've got to put my boundaries. I'm going to say x, second math, which pulls up the test, greater than 0, which is option number 3, greater than 0. Close my parentheses. Now what I want to point out is that I want you to notice that I have 2 sets of parentheses. So I'm saying I have this stuff, and then I have, actually I might need a third set of parentheses.
Why? Where?
Well, because I want this x minus 6, I want that to be the x minus 6 over x, I need that in parentheses. So what I'm going to do is I'm going to insert, so I'm going to hit second, insert, open parentheses, now I need another set.
You mean like after the x plus x over 0?
Oh,
Yeah.
okay,
more
yeah. So you separate the 2 piecewise functions, or the 2 parts of that function.
And then I got to go insert, and then I got to do this. All right. So now I think I got it.
Do you have to do that to the bottom too?
No, because 1 over x squared is in parentheses. So I think I have it. Let's graph it and see. Okay, boom. There it is. So we have a jump discontinuity at 0, right? We have a left-sided limit that approaches a value, and then my right-sided limit approaches infinity. So the question is, let's go, well, what's the limit of f of x as x approaches negative infinity? Oh, they're asking a different question. All right. So to solve that, I'm just going to go in this direction. So what is that? Well, as we go in negative infinity, we're gonna focus on this x squared, right? Or I mean not x squared, the x minus 6 over x minus 3. Remember that as we approach positive or negative infinity, these values are insignificant. So I really have x over x. What does that reduce down to? 1. So I would suspect that this approaches 1. One way to verify that is just to go to the table of values, and I've got to change some things. I'm going to hit table set, and I'm just going to put like a large negative value in there, and then hit table, and look, it's 1.0003. Does that make sense? Graphically, the only thing we're doing is we're going in this direction, right? And if you keep going in this direction, you'll see that the y value, if I keep going in this direction, it'll be closer to 1. All right, I got to go really, really negative though to get to 1. All right, so that limit is 1. Now, as we go towards positive infinity, which is another question that they're asking us, what's the limit of f of x as x approaches positive infinity? Well, same thing. I'm just going to come in here, and I'm going to go like this. All right. So now, as I do that, it looks like 0, and that would make sense because remember, this is going to be modeled by the function 1 over x squared. So really, what we're going to have is 1 over infinity squared, or 1 over infinity, which is just 0, right? So that limit is equal to 0. Now, lastly, what they want us to do is to study the behavior of the function as x approaches 0 from negative infinity. All right, so now to do that, we're just going to look at this graphically, and and see what that value is, and then we'll try to figure it out. I'm going to guess as it gets close to 0, well, think about that. I could plug in 0, can't I? Right? I could just say, can I just say 0 minus 6 over 0 minus 3? Right? And that's just negative 6 over negative 3, so it should approach what value?
2.
2. So this should approach 2. Let's see. Yeah, so let's plug in like a really small negative number. Yeah, 2, right? Does that make sense? Now the only other issue that we're really going to run into is when we take the limit of the function as x approaches 0 from positive infinity. And that just means we're going to come and go this way. But what's that limit?
Infinity.
Infinity. All right, so that limit is infinity. So we've got 1, 2, 0, and infinity.
D.
Is it D? Yeah, I
Yeah.
think so. I don't know what the order is, but D has all the right answers.